Hello, it's Mr. Kaplan here, and today I will be starting the first lesson when it comes to the volume and surface area of the different shapes we'll be seeing in this chapter here. But today we'll be focusing on the volume of two shapes in particular, which is prisms and pyramids. And roughly with the prisms, there's actually two shapes within that we're also going to look at. Now, before I officially start this lesson here, I just want to quickly introduce you to the formula sheet that we'll be looking at in this chapter. So if you take a look at your notes, you notice you will have a formula sheet that looks something like this here. And what we're going to look at here in today's lesson, if you take a look on the right side and you're looking at the last three shapes, okay, we will be looking at those last three shapes and the formulas on the far right hand side there. Okay, so make sure you have that handy as we go through the lesson, so it'll make things easier to understand as we go through this lesson here. All right, so let's get straight to it here and see what we need to deal with when we're looking at the volume of prisms and pyramids. So the first thing we need to know here is exactly what volume is. So what volume is the amount of space that an object takes up. A good example of this is that if you take, for example, a bottle of water, okay, the water inside the bottle, okay, that's an example of volume because the water takes in the shape of the object. In a similar fashion, let's just say you had a box, okay, and you put stuff inside the box, okay, the stuff inside of the box, okay, would be the volume of that box there, okay. So that's just a nice way to picture what that is. Now, when it comes to volume, what's important are the units, okay. The units are always expressed in what are called cubic units. So for example, if your measurements are in centimeters, then the volume would be centimeters cubed. If it was inches, then your final answer will be inches cubed for volume. So everything will always be in cubic units. All right, so for prisms here, all you're going to see here is that you're going to be taking the base, which tends to refer to the bottom of the shape here, and you're going to multiply it to the height, okay, and the length. Now, quite often, the most common formula that you're going to see, and you have this on your formula sheet there, is that this can also be expressed as length times width times height. And the way, what happens over there is that where the base is, okay, that tends to be expressed as the width there, all right? So just um, a little bit of definitions in terms of what the different formulas that you use are. But when it comes to rectangular prisms, length times width times height is the common formula that is used. Okay, when it comes to the volume of triangular prism, okay, what you would have there would be base times height times length divided by 2. Okay, so when you're labeling a triangular base prism, the base refers to the entire bottom of the triangular face here. Okay, so that's the base. Now the height itself is the vertical line, okay, or the vertical height that goes from the top corner to the opposite side, and it cuts it in half. Okay, if you have, for example, an equilateral triangle or an isosceles triangle. Now the length again would be the other measurement when it comes to the rectangular face there. All right. Now, when it comes to triangle prism, just to break down the different parts, okay, triangle prism consists of two triangular faces and three rectangular faces. Okay, so just to mention that. And the reason why I mentioned that, because the next shape that we're looking at is a pyramid. Now, with a pyramid, what you have here would be either a square base or square bottom or a rectangular bottom. So when it comes to the bottom, what you would have there would be the base, okay, and the length. Now, the height itself is the vertical height or how tall the pyramid is. Okay, so that's what you need to know about the pyramid. And quite often, again, people ask, how do we know the difference? As I said before, when it comes to the pyramid, there's four triangular faces and either a square or rectangular bottom. All right. Okay, so let's see some number crunching here. So the first thing we're going to look at here is rectangular prism. As I said before, the most common formula to use here is length times width times height. So once you write down the formula, what you have to do next here is to label the sides according to the letters that you have. So the width here will be the 30 centimeters. Okay, the height here would be the 10, and the length here would be the 50. Okay, put the numbers in, and then from there, you'd get a final answer there, 15,000 cubic centimeters. Okay, always get in the habit of labeling the sides first, because in some cases when you label the sides, you will discover sometimes that you are missing a measurement. So it's a good habit to get into. All right, the next thing I'm going to do here, we're now going to find the volume of rectangular base pyramid here. And all we're going to do here, again, use the formula base times height times length divided by 3. So essentially for the base is the bottom of one of the triangular faces here. So in this case over here, the base here would be the 112. Okay, the height here would be the 65, and the 66 here would be the length. All right, and all we're going to do here is put those numbers into the formula. Okay, and then do it step by step here. So in the next step here, I'm going to multiply all the top numbers together, and that's going to give me 480,480. And then we'll take that divided by 3, and the final answer will be 160,160 cubic millimeters. Okay, so notice so far the first two questions we looked at, just put the numbers into the formula, okay, and then calculate it from there. All right, for the next example, I want you just to take a look at your formula sheet, for example, and I want for a moment. And what I want you to do there is to take a look at the diagram for a triangular prism, okay? And the reason why I want you to look at your formula sheet, okay, for the volume of the triangular prism, because I also want you to take a look at the diagram that's on the screen there, as well as in your notes, okay? Now, what I want you to compare here is to see if there's anything missing in this diagram, okay, that happens to be in the diagram on your formula sheet. Okay, now another thing you could look at is that if you decide to just plug these numbers into the formula right away, you'll probably notice you're missing a measurement here. Okay, and guess what that measurement is? Okay, it's actually the height of this triangular based prism here. So our first step, believe it or not, in this question here is we need to solve for that height. So notice on the screen here, the height that we're going to solve for is that bluish line that's going vertically here. So I'm going to just take that triangle and I'm just going to blow it up here so you can see it bigger. And what we're going to do here is we need to solve for that using Pythagorean theorem. Now what I want you to see here is that that blue line cuts the bottom side exactly in half. So since the entire bottom there is 16 feet, when I cut it in half, that bottom of the right triangle is now going to be 8 feet. Now, if you take a look at the diagram over here, notice there's 3 red ticks. These 3 red ticks display to me that all 3 side lengths there will be 16 feet. So the hypotenuse of this right triangle is going to be 16 feet there. All right. Okay, so let's label and solve here. So this is the formula for the Pythagorean theorem. Now remember when we did the Pythagorean theorem, I always labeled the hypotenuse first because it was the easiest one to find, okay, because it was the longest side of the 3 sides there. And if you put a box in the bottom left-hand corner, okay, it's also the side directly across from it. So the 16 here would be the C. I'm going to set the 8 here to be the A. And in this case here, we'll be solving for the B. Okay, so let's put the numbers in. And what we're going to do now is simplify the numbers. So 16 squared gives me 256. 8 squared gives me 64. And we're now going to solve for the B. So that B squared is going to stay where it is. So what we need to do is we need to take the 64 and then subtract it from the 256 when it goes to the other side. And last but not least here, we're now going to take the square root of both sides. Okay, and this is going to give me a measurement here of 13.9. So now that we have that, the 13.9 now is going to be the height. So we now have all the information that we're going to have in order for us to solve for the volume of this shape. So let's do that. Okay, so as I said before, if you try to put the numbers in first into this formula, okay, you'll probably notice that there was no height given to you. So that's just another way that you can figure out that you do need to solve for the height using Pythagorean theorem. So we're going to put the numbers in accordingly. So the base again is the bottom of the triangular face. Now the base is now going to be the entire bottom there. Okay, the height is going to be the 13.9 from the previous slide, and then 25, that's going to be the length. So we're going to put those numbers in. Okay, so we're going to multiply the top 3 numbers there, divided by 2 at the end. So the volume of that triangular base prism is going to be 2,780 cubic feet. All right. So that wraps up the first segment of the volume of the shapes that we're going to see here. So until the next lesson, I will see you then.